In most of our documentation, and in the remainder of this presentation, you'll see the peripheral labeled RTCC, which is Microchip's acronym for Real-Time Clock Calendar. The RTCC is a sophisticated clock, calendar, and alarm function which allows a user to easily read and display a time and date. It also allows the device to wake up at a specific time in the future. The RTCC is fed directly from an external 32 kHz clock source. The 32 kHz signal is fed into a prescaler that provides the internal registers of the RTCC with a half-second pulse. The half-second pulse is used by the peripheral to update registers that contain data for the year, month, day, weekday, hour, minute, and second. These registers contain the time data in easy-to-use binary coded decimal, or BCD, giving the user time and date information in the format most often required to display it. Alarms can also be set based on the month, day, week, hour, minute, and second. You will notice that all the registers utilized by the RTCC itself are in the slow-speed RTCC clock domain. This allows the RTCC to function even when the CPU itself is not, such as in a sleep mode. This minimizes the module and device power consumption. The alarm function can be set for a specific time and to repeat based on a variety of time frames, including a yearly, monthly, weekly, daily, hourly, every minute, every 10 seconds, or every second. The alarm can be set to repeat up to 256 times or to repeat indefinitely. One potential use for the alarm repeat function would be to generate an internal interrupt, such as waking up every 10 minutes for a Zigbee protocol application. The output signal of the RTCC can be used to either generate a continuous 1-second pulse or to act as an output for the alarm function itself. The CPU itself accesses the peripheral through various RTCC and alarm control and value registers located in the CPU clock domain. This allows the CPU to access the data at full speed. Reads and writes occur by writing to the appropriate bits in the RTCC calibration and configuration register or the alarm configuration register, and then reading from the RTCC value register or the alarm value register. The value returned will be determined by the RTC pointer or the alarm pointer bits in the configuration register. When the pointer bits are set to 1-1, the year value is returned, and the pointer bits are decremented, making the next read 1-0 or month and day. Additional reads will return weekday and hour and minute and second. This allows reads and writes to a specific register or to all data registers in 4 sequential cycles. The RTCC also includes a periodic timer adjust function to allow the user to calibrate the timer for specific oscillator sources. This function allows the specified number of counts to be added or subtracted from the prescaler every minute. The calibration factor is determined by comparing the timing of the RTCC with a known clock and calculating the required adjustment. The use of the periodic timer adjust function allows the RTCC to achieve 3 seconds per month accuracy. When you're first using the RTCC, there are a couple other resources that you may find of interest. The first is a tool called Visual Initializer. Visual Initializer is available under the Tools menu of MPLAB IDE. Visual Initializer can be used to generate the initialization code for most of the peripherals on the PIC24. When you click on one of the general categories on the left, it opens up to show what peripherals are available on the device you've chosen. First, you drag the peripheral block to the device. You can then click on the block to bring up a small menu that allows for basic configuration. In addition to initializing the peripheral, Visual Initializer will generate reports on interrupt usage, register usage, and pin assignment. A second resource is our Explorer 16 development board. It's our primary tool for demonstration and development with the PIC24F family. Sample code for the RTCC in the form of the file rtcc.c is included with the development kit. For those of you without an Explorer 16, All code and documentation can be downloaded from the Explorer 16 webpage. Now for a quick review of the RTCC, we'll take a look at how the RTCC can benefit a designer. First, the RTCC creates a very easy-to-use clock function. Once set, there is no need for software to calculate the time, date, month, year, or to adjust for a leap year. This eliminates most of the software involved in implementing a real-time clock calendar in software. Your software interfaces with a few configuration and value registers to set and read data. All the values are stored in BCD, providing the data in the format you're most likely to need it in. The registers are maintained by the RTCC in a low-speed clock domain, making the peripheral very low power. The RTC makes alarm functions very easy to implement. Alarm masks allow you to very easily set recurring tasks with a number of repeat time frames. Every day at 8 o'clock is no problem. Finally, the calibration function makes it possible to achieve 3 seconds per month accuracy with the RTCC.